Hello, today we are going to discuss modes in Hadoop, and we'll also discuss about little bit concept of map reduce in Hadoop too. So in the last sessions we have installed a Hadoop and VM as well. On VM we installed Hadoop. So we'll try to understand like what are the different modes that we can install Hadoop. So let's discuss all the three modes. The three modes are standalone mode, pseudo distributed mode, fully distributed mode. So let's first discuss about standalone mode. This is the standalone mode. So what are the daemons that we have? Name node. We have name node. We have data node. Okay. This is at parent label, and this is at the slave. Then we have resource manager. Then node manager. Okay. So we have 4 daemons that we already discussed. So these daemons are actually running in a single JVM, single instance of Java. If you have gone through my previous video, then you could have understand like what is name node, what is data node, what is resource manager, and what is node manager. Okay. Also, in Hadoop installation, I have shown you that how these daemons are running. By using a command called JPS, I was able to show you that okay, these daemons runs once you start the Hadoop cluster. Then what I will say, single JVM, single instance of Java. Single instance of Java is running entire cluster. I won't say even it's a cluster, I'll say in a local mode. Okay, single JVMs. Then one more thing, single VM box, single VM virtual machine, I'll say virtual instance, single virtual instance, single JVM, and single JVM and single virtual instance is used. So now you will say then how name node, data node, resource manager and node manager are running. These are running in a single JVM on different threads. Thread is nothing but a part of a program. So these are running on different thread but on a single JVM. Okay, so how we can install this standalone mode? So there's nothing to configure into it. The way we configured, that much configuration is not required. You just need to untar the Hadoop folder and just start using it. That is, there's no concept of local mode. There's no concept of HDFS or anything. It's completely local. You just need to configure one Java home, that okay, this is your home directory. Okay, so this is all about standalone mode, and it is a default mode of Hadoop. Means if you have not done any configuration, then you will get this mode. So I have written few points on it. It is the default mode, one node only, that is your one instance. No separate process will be running. When I say process, means only one JVM, only one Java JVM will be running. Everything runs in a single JVM. Small development, if you are doing some small development or you are doing some testing or debugging, then you can use this standalone mode. Now our next mode is pseudo distributed mode. So we'll discuss about that as well. So this is our pseudo distributed mode. What is pseudo? Pseudo means something which is not real. We are trying to make it. Okay. So here also we have one instance, which is your virtual machine VM. You have your one instance. Okay. And but we have different here also all the daemons will be there. Name node. Okay. Then data node. Then your resource manager. Then your node manager. So what happened in this scenario? I think I'm missing one. Okay, secondary name. These are like, if you remember in the JPS, if you'll do JPS, if you install your Hadoop and run that command JPS, you will be able to see at least these 5 daemons. And the one is name node, another one data node, resource manager, node manager, and the secondary name. So once you run, once you will go through my video, you will see in the installation video, you will see like how I am able to see the daemons are running or not. Okay, so these daemons are running on separate JVM instance. These daemons are running on separate JVM instance. All are separate JVM. So one JVM crash, that won't affect other. It's not running on thread. Separate Java instance. I'm again saying in very normal term, separate Java instance means separate JVM is there for each daemons. Okay, so that is what we have configured. So what are the things that is here? What are the things that is here? The first thing, single Ubuntu system, I'll say in very basic term, instance. You have single Ubuntu instance, and you have single Ubuntu instance. How many JVMs are there? 1, 2, 3, 4, 5. 5 JVMs required to run this cluster. Okay. So what I would say, the installation that we have done is a pseudo distributed mode, because we have done some configuration and we were able to see all the different processes were running on different JVMs. Okay. So this is the pseudo distributed mode. I have discussed few points on it. One box but different JVMs. A single node but cluster will be simulated. We are trying to simulate a cluster on a single distributed mode. Okay, on a single system, that is a single distributed mode that we are doing. So we are trying to simulate a cluster, but in a standalone mode there is no concept of such cluster or anything. But in a pseudo distributed mode, we are trying to set up a cluster. Then daemons will run on separate processes. That's what I have discussed. Now separate JVMs, and it is used for development and debugging as well. Okay. So this is what we have installed, pseudo distributed mode. Now let's discuss about fully distributed mode. So fully distributed mode is what I can say. Okay, let me do it here only. I'll say it's a fully distributed mode. fully distributed mode. Now in the fully distributed mode, what happen? You have one cluster. The outer line is your cluster boundary. But inside your cluster, you would have different system. So 1 minute please. I'm saying system, different Ubuntu system, I'll say. Okay, so this is on this is on one Ubuntu system, I'll say. This is on another Ubuntu system. This is another Linux or Ubuntu system. And I'll say again, like, let me copy it. Or a slave nodes are I'm adding all slave nodes. There can be more than one, so I'm just adding 2. Okay, so this is on another, this particular section is on another system, this particular section is on another system, this master node is on another system. So what is this? This is your master node. If you have gone through my previous videos, I have discussed this. This is your master node. These are all your slave nodes. Slave node. This is again a slave node. Okay, and this is also a kind of another system which is waiting, which will help the name node. So there is other concepts that I have discussed. Just I have given just an overview and how journal nodes work. So we'll slowly discuss about all those things in further videos, in further sessions. So now you can see we have how many instance of VM we have here. How many instance? So we have 4 instances. Okay, 4 instances of virtual machine. So let's not talk about how many JVMs, because in this I'll calculate, okay, 2 JVMs, in this 2 JVMs, 2 JVMs and 1 JVMs. So it will overall give us 7 JVMs. That doesn't make sense to count here. So this is your completely fully distributed mode. So what I can say, multiple nodes for this, multiple nodes with cluster. Daemons will run on separate processes, separate JVMs, and it is used for development and debugging. So this is your fully distributed mode. So that is most of the time this happens in your real time scenario. In the real time when you will work on a fully distributed mode where everything won't be in your system. You will be connecting to the cluster either through some software called as putty, which will help you to connect to the cluster. And different systems, different nodes, various nodes are connected to a master node. So that would be the reality when you will work in Hadoop. But for learning perspective, we made a pseudo distributed mode, and that on which we will work and learn as well. Now, if you remember, I have done few configuration in Hadoop during my installation. Okay, one is Hadoop environment.sh, HDFS site.xml, core site.xml, and MapRed site.xml. Okay, so let's see like how and what configuration I have done into it. Let me start the VM. Okay, so let me see the configurations that we have done. So the first thing is Hadoop-env.sh. Hadoop-env.sh. So if I'll open, no, it will be like this. 1 minute, I'll try to make like this. cd/user/local/Hadoop. Yeah. Then we'll go to cd etc, okay, /Hadoop ls. Now this is your all the configurations file. Okay, so we are talking about Hadoop-env.sh. so Hadoop-env, so I say vim Hadoop-env.sh. What are the configuration I have done? I have done something related to OPTS, some warning, and then the Java home directory that I have already mentioned, that you need to give some Java home. If you are interested in giving some heap size, name node size, or name node OPS, then you need to provide that in Hadoop environment.sh. Okay, now let's go to hdfs site.xml. Let's go to hdfs site.xml. Okay, so I'll say vim hdfs-site.xml and open it. Now I've just defined only one thing, but what are the things you can define? That is the replication factor. Guys, I have discussed this replication factor concept in my previous videos. When suppose that is the cluster never have only one copy of a block. Cluster maintain different copies of a block, so that if any node will go down, then it will depend on another copy. So it's just not dependent on a single block. So how many copy it will make, that is getting decided through replication factor that you have defined here. So see, I am just working on single node cluster, so I just defined the replication factor dfs.replication as 1. And what are other things that you can define? You can define your name node directory, you can define your data node directory, you can define your data node address, web address, HTTP ports. These are not required now. Now, core site.xml. Let me talk about some core site XMLs. Okay, vim core site. Okay, now in the core site, what are the things? Configuration related to HDFS and cluster, security configuration, temporary directory, define file system access URL. See, I have defined my temporary directory for any, saving anything or anything, and also file system default name I have defined here. Okay, file system default name configuration related to HDFS and cluster. So what is the file system here? HDFS. So what configuration I am doing? I am defining here the default name means the port, that is nothing but the localhost 54310 on which HDFS, your Hadoop distributed file system, will run. I have also given the description. So once while doing installation, please go through all the description and understand what actually you are trying to do. Now, our last file is mapred site.xml. Okay, vim mapred site. Okay, I opened it. Now what it is telling? Now in the mapred site XML, I am defining the tracker, the job tracker. The job tracker is nothing but your resource manager nodes, that where actually it will execute the host and port that the MapReduce job tracker runs it. Okay, node manager details, that is nothing but your node manager detail only, host and port that I have defined. Job history location, if you want to define, okay, MapReduce task time, you can define, and the MapReduce task temporary directory. Now from the past couple of videos, I am only talking about MapReduce. So what is this MapReduce? I must say MapReduce is a heart of Hadoop. So whatever work you will do, it will perform a MapReduce job. Whatever work you will perform, it will perform a MapReduce job. Okay? So MapReduce site XML is more about your slave nodes configuration. Okay. Slave node configuration. Now let me describe everything here. What are the things in what are the MapReduce thing in a pseudo distributed mode? In a pseudo distributed mode. This is your pseudo distributed mode. Oh no. This is a single mode. Okay, let me make it pseudo distributed quickly. Now let me describe it how actually things will work. Okay, please watch it very carefully. I have already discussed in previous video, but I am giving you more clarities in it. Okay. Now you have one file. This is the file. You have one file called as words.txt. words.txt. Okay. Now its size is, let's say, 560 MB. Its size is 560 MB. Okay. Now the first thing what I want to know, that what is the default size, what is the default block size in Hadoop 2? What is the default block size in Hadoop 2? Default block size. I have discussed about what is block and everything in my previous videos. What is default block size? Means one block, how much, what is the capacity of one block? So the capacity of one block is 128 MB. Okay, from Hadoop 2, earlier it was 64 MB in Apache Hadoop. Okay, now it's 128 MB. Now tell me the next question. What would be the number of blocks? What would be the number of blocks here? Number of blocks. What will do? Calc C. Sorry. What will do? The size of the file divided by the block size will give us number of blocks. Now it's 4.375, means 4 is full, 3.375 more required, means total number of blocks would be 5 blocks. So how many blocks is there? 5 blocks. So what I would say, B1 size is how many? 128 MB. Okay. Now B2 size is 128 MB again. Now B3 size is 128 MB. Okay. B4 size is 128 MB again. Then B5, and this is nothing but the remaining one. So the remaining will be 512. It should be 48, right? Yeah, 48 MB. So when you will put this word.txt into this cluster, okay, into this cluster, then it will divide the file into 5 blocks and stored into your HDFS. Okay, so suppose this is your Ubuntu system, Ubuntu Control Alt T I have done. This is my Control Alt T system. Okay, in Control Alt T I have already started my Hadoop cluster. So I'll write a command called as Hadoop fs hyphen put. This is a command. Hadoop fs file system hyphen put. What I want to put? I want to put this words.txt. Words.txt. Okay. Now you want to put. Where you want to put in the HDFS? You need to define a directory here as well. So I say I want to put it slash words slash. I want to put in the root word slash. So what happened? This words.txt will move to cluster. Oh, sorry. It will move from here, right? Yeah, it will move from here. It will when you will execute this command. Let me change the color. Make it green. Okay. So it will go to the name node. Okay. Because you just executed this command. Then this name node will send it to the data node, and data node will take care, because there is only one single instance. So all the nodes like B1, B2, B3, B4 and B5 will be inside here. Okay. Once again I am repeating, and the path will be slash words. This is your words.txt 560 MB. You open your Ubuntu terminal and you just executed this command. The moment when you run this command, this file will be moved to the HDFS and will be split it into 5 blocks: B1, B2, B3, B4, B5. Now, suppose I have written one map reduce program. Okay, and let's say my program name is wordcount.jar. Okay, and I asked and I'm executing this jar onto the cluster. So you can do it in two ways. Either you can run it through Eclipse also. That's not a big thing. Yeah. So I'm executing this jar on this cluster. So what happened? This jar will go to the resource manager first, and the resource manager will give this to the node manager in order to monitor this execution of this jar. Okay, and what node manager will do? Node manager is having a separate instance. Node manager is having, I'm just extending it, doesn't mean it's outside. Node manager having a separate instance called container. Okay, so what node manager will do? Node manager will create a separate instance which is nothing but the container, and in this container your map reduce job will be executed. Means your word count.jar will be executed here. Okay, and wherever it is required, suppose this word count jar is using words.txt, it will take the word by word from each block: B1, B2, B3, B4 and B5. Okay, now next thing word count.jar is a Java file which is nothing but a Hadoop related file. Okay, so whatever you do in Hadoop is a map reduce. Okay, so in a map reduce job, you are writing a Java file, but it is nothing but a map reduce job. There is a two phase. One is called mapper and another one is called reducer. One is called mapper and another is called reducer. So what happened? Your mapper and reducer both will be executed inside this container. Inside this container, your mapper and the reducer job. If you have reducer, so both will be executed inside this container. Okay. Okay. So so suppose now you can ask, like, why this node manager is itself a JVM, separate JVM? Why it's not executing this mapper and reducer inside itself? So the reason behind it, let's say tomorrow this node manager goes down, then or because of some code in jar, your some exception, this fails, this JVM entire fails, suppose. So what happened? This entire node manager will go down. That's why node manager create a separate instance, okay, inside which, that is nothing but a container, inside which mapper and reducer job gets executed. Mapper and reducer jobs get executed. So tomorrow if it is failed, so this container will fail. Nothing will happen to the node manager. Okay. Now the next question. Suppose in this jar, it can be very big jar. Okay. I have 5 mapper job. And I have obviously 1 reducer. 5 mapper and 1 reducer. Why 5 mapper? I'll tell you later. 5 mapper and 1 reducer. So who will define the number of map and reduce job that will be executed at a time in the container? The number of map and reduce job. Okay, so if you'll go through my concept here, MapReduce site.xml, it is talking about node manager details and MapReduce timed out, MapReduce related, all the stuff inside the slave node. So you will define your number of MapReduce tasks in nothing, in nowhere but in MapReduce site.xml. And what is the configuration? What would be the configuration? The configuration I have mentioned somewhere. Okay, I have not mentioned. I'll come to that. I'll come to that. So we have to define this configuration here. So that will tell us, like, okay, these are the number of containers that you can do. That's it. But when it comes to pseudo distributed mode, things will be little bit similar. Let me copy this, guys. Okay, same file, same thing I'm doing, and this is your fully distributed mode. What happened? Fully distributed mode. You fire this command hadoop fs-put words.txt/words. What happened? This will go to your name node, and what name node will do as per the okay. One more thing I want to say here. As per the availability and as like it's not sure, like, okay, all the nodes will come here. It might be the case like name node will give it to the 1 minute. Name node will give it to the okay. This is not perfectly done. there is one mistake here. Just trying to show some parent-child relationship and it gone actually. This will never reside in master node. Okay. Now this will come the data node. Oh, sorry. Okay. Now this name node will come inside, will contact data node. This name node will send the data to the data node, this data node. Okay, and these distributed blocks will come here. B1, let's say B3 came here, and let's say B4 came here. Okay, now what are the left outs? B2 and B5 came here. Okay, fully distributed in different event system. Now I'll say replication factor, that is RF, is 2. Means each node will be replicated twice. So what happened as per the replication factor? What happened? B1, B3, B4 here. Then what are the things left? B2, B5 will be here. Okay. Now rest of the things are B1, B3 and B4 will be here. Okay. So this is what the meaning of replication factor, and that is what we usually define inside SDFS site.xml. Okay. Now I'll send my word count.jar to this cluster, which will go to the resource manager, and resource manager will give it to the node manager. And what it is giving? It is giving word count.jar. So word count.jar is here. Word count.jar is here as well. Okay. Now the remaining concepts are same. Remaining concept is same means it will create a separate instance. Node manager will create a separate called container, and it will execute the number of mapper and the reducer inside it. It will execute the node manager. And also I told in the previous sessions that this node manager will keep sending a heartbeat at the fixed interval of time to the resource manager. In the fixed interval of time, it will keep sending the heartbeats. So the moment when it will stop sending the heartbeats, it means this node goes down. Okay. So yeah, this is about like your. Let me discuss few more things left outs, which is the map reduce overview. In the Hadoop to argue the concept of map slot has been replaced by. So you see, this is like something extra read for you guys. Like if you'll go through it, you will understand that okay, what are the things. I mean, yeah, this is the configuration I was talking about. Map reduce the task at a reduced task maximum is the one which decides number of mapper and reducer job inside the container. Which decides number of mapper and reducer job in the container, that how many mapper and reducer job will be executed. Okay. Now if you read this, you will understand that what was there in the map reduce 1 and what is there now in a map reduce 2. Okay. So in the map reduce 1 there was a concept called job tracker and task tracker, but there is no such concept here when in the Hadoop 2, that is map reduce 2, which is nothing but a yarn. That there's a concept called resource manager and node manager now. Okay. And what are the features of resource manager, and what are the differences of the node manager? Please go through this. I'll forward this document to you guys. I have already discussed, but if you'll read this, you will be able to answer few questions if it is asked in the interview. So I have discussed these things. So yeah, so that's what. Let me read this line at least. In the new Hadoop 2 architecture, the concept of map and reduce slot has been replaced by container. So earlier we have a definite slot for mapper to execute and a definite slot for reducer to execute. So suppose if I have 10 mapper and one reducer only, suppose okay, this is your slot. So this is your map slot, okay, and this is your reduce slot. This is your reduce slot. This is your mapper slot. Now I'll say I have 6 mapper. I have 6 mapper and 1 reducer. So what happened? 4 mapper will be executed at a time and 2 mapper will wait. Okay, and the reducer in spite of having 2 slot, the reducer will be executed, but no mapper will be allowed to execute inside this slot. Okay, so there was a boundary, but now it is just a seamless. There's a container concept. So there's nothing like a boundary for mapper to execute or a reducer to execute. Okay. So earlier there was separate slot for execution, but from Hadoop it's seamless and there is no such specific slot for any job, which is again configurable for each node, and configuration is nothing but inside this, and in the mapred site.xml you can define it. Then about yarn, I have written Hadoop MapReduce 2 has replaced old daemon process, job tracker and task tracker with yarn component, resource manager and node manager that I have already discussed. I have discussed these things, guys, so just go through these points. It's very useful. So this is it for today's session. In the upcoming session I'll discuss about a very famous example of Hadoop that is in the MapReduce, which is a word count example, and I'll also go through some HDFS basic command, like how we can, like we have seen how we usually get and put the files. How we usually get and put the file. So I've just executed the put. So how to get the file, okay, how to make a directory inside that, and how to list out what are the files inside the HDFS directory. We will play around all these commands in our upcoming classes, along with a very famous example called as word count example in our upcoming classes. Also, one advice, like when I am teaching you guys this through diagram, while going through the videos, you should keep a notebook and a pen ready, so that when whatever diagram I am drawing, you guys also should follow that, so that it will give you more clarity in that. So I'll be sharing these documents once you enroll for our live sessions. So thank you. This is for today.